So let's have a look at this next transformation. This is called a one-way stretch parallel to the y-axis. Now again, this is going to affect the x coordinates, not the y coordinates. Let me try and explain to you why. If you just have a look, that number, remember I know it's a letter, but that letter is standing for any number, is inside the function. It's not on the outside of the function, it's actually within the function. So if it's within the function, it affects the x coordinate. Very similarly to that last translation I showed you, it actually affects the x coordinate in exactly the opposite way. Okay, so in this particular case, if that a was the number 4, instead of multiplying each of the x coordinates by 4, it actually has the opposite effect. So remember, the inverse operation to multiplying by 4 is to divide by 4. So what it would do to all those x coordinates, it would mean it would divide them by 4. What it actually does is it means the y-axis, okay, stays still, okay, because remember all the y coordinates aren't changing. So what it does is it takes all these x coordinates and it stretches them, okay, either towards the y-axis or it moves them away from the y-axis. So what does it do to the original graph? It's either going to squash the graph up, okay, or it's going to pull the graph out. So it's very, very similar to the one that we did when we did it parallel to the x-axis. So it was the x-axis that was staying still and we were pulling those y coordinates either like that, okay? But in this particular case, it's the y-axis that's going to stay still and we're going to be coming in like this or coming out like that. Okay, so let's have a look. We're going to transform this original graph, okay? So we've got 3 coordinates to look at. The coordinates we've got are -2, 0, 5, 4, and 8, 0. And we're asked to draw the graph of this transformation, f brackets 2x. Notice the 2 is inside the bracket. If that 2 was outside the bracket and was here, so it was 2 times the function in x, that's the one where it affects the y coordinates. So remember, if it's on the outside, it's affecting the y coordinates. If it's on the inside, it affects the x coordinates, but remember, in the opposite direction. So let's have a look at our coordinates. We've got -2, 0, we've got 5, 4, and we've got 8, 0. All those y coordinates are going to stay exactly the same. So that y-axis is going to just stay there, like that. So let's have a look what happens to these x coordinates. Because it's times by 2 inside the bracket, what it's actually going to do is going to divide each of those coordinates by 2. That's why we say it has a scale factor of 1 over a. Our value of a is 2. So what we're literally doing is we're halving all those x coordinates. We're dividing them by 2. So -2 would now shift to -1, 0. 5, 4 would shift to 2.5 or 2.54. 8, 0 would shift to 4, 0. All we need now to do is plot those coordinates and just see the effect that that has on the graph. So -2, 0 has now moved to -1, 0. Okay, 8, 0 has come into 4, 0. 5, 4 has gone to 2.54. And you can see what's happened to that original graph as I'm just sketching this one. It's made and pulled it into the y-axis. Now, if this was a half x or a third x to start with, what's that actually doing is it's dividing by 2 or dividing by 3. What would that do? It would change the x coordinates in the opposite direction. So a divide by 2 would come to times by 2. Divide by 3 would come to times by 3. So what would that then do? Think about it. If it was a half x or x divided by 2, 8 would go to 16, so it pulls out. -2 would go to -4, so it pulls out. That 5, 4 would go to 10, 4, so the graph is being pulled. It's being stretched parallel to the x-axis, with that y-axis being the axis that we're stretching it on. So, to summarise at the moment then, we've got 4, okay, transformations. All right, 4 transformations. We've got 2 translations and 2 stretches. Okay, remind ourselves of the 2 translations. Two translations are when we have the number being added or taken away on the outside. What does that affect? That affects the y coordinates. But this is also a translation. Notice what's happened to the number. The number's dropped within the bracket. So that's the one where it affects the x coordinates. So this one translates the graph up and down. This one translates the graph across that way, in the opposite manner to what you expect, because it changes the x coordinates in the opposite way. Then what did we do? We were then multiplying by a number. So if I suddenly put that number on the outside, what does that do? It affects the y coordinate how you would expect it to. So say that number was 3, fx, it would times each of the y coordinates by 3. So what's happening to the x-axis? It holds. All those y coordinates have been times by 3, so it's stretching it up like that. Okay? Or if it was underneath, stretching it down like that. Suddenly, if I put the number on the inside of the function, like we've just done here, what does that do? It affects the x coordinate because it's on the inside, and it affects it in the opposite way to what you expect. So it would divide each of those x coordinates by that number. So what's happening? Y-axis is staying still. We're pulling inwards or we're pulling outwards. We're stretching inwards or stretching outwards. We're just going to have a look at what happens when we put a negative sign, okay? Either on the outside of the function or on the inside of the function. Thank you.